This is 3.11 related rates, number 23. So you have a 13-foot ladder. They're nice. They labeled it 13 feet. So that's the length of that ladder. And it's leaning against the vertical wall. You see that. When Jack begins pulling the foot of the ladder away from the wall at the rate of 0.5 feet per second. So I guess this is Jack. He's pulling this ladder away from the wall at the rate of 0.5 feet per second. So I'm going to circle that. Jack begins to pull the foot of the ladder away from the wall. Okay. That we need to interpret. I see the word rate. It's a derivative. So in my head, something's changing as time changes, and it's changing 0.5 feet every second. What's changing? What's changing is the question. So in red, we know that's moving that way at 0.5 feet per second. We need to write that as a differential equation, as a derivative. So my question in your head, you should be thinking, what's changing? Now, here's why a lot of you don't like these problems. Because you have to decide a variable. They don't tell you, use this variable in this problem because this one will work. You actually have to, in your brain, come up with the variable. So you have to decide, hey, what's changing at 0.5? There's some distance that's changing. What distance are you going to use? The very logical distance is the distance from the ladder to the wall. That should be your distance that's changing, right? So next, what do we call that distance? You have to decide. You can call it whatever you want. Some might say, hey, I like B because that's the base. Some might say, I like X because that's kind of like the X-axis. Someone might say, I want C because that's concrete. And someone else says, no, that's asphalt. I want to use A. You get to choose whatever letter you want. And so you need to be comfortable with that. Some of you kind of freak out with that freedom because it's kind of like, I don't know what to do. So I'm going to choose, let me pick something. I'm going to call it B for the base. Now we can make some sense of this. What's changing 0.5 feet every second? B is changing, the distance from the ladder to the wall. So I can say the change in the base as time changes is 0.5 feet per second. And now my next question is that positive or negative? Well, is B increasing or decreasing? In my eyes, B is increasing. So therefore, the derivative should be positive. So there we go. There is my first rate. Okay, so if you break this down and really think about what's going on, it's not too bad. Next, how fast is the top of the ladder sliding down the wall when the foot of the ladder is 5 feet from the wall? So they want to know how fast the top of the ladder is dropping. Wow, how are we going to do that? How fast? Now, here's where you have to interpret again. You have to go from English into calculus. How fast is asking a rate. How fast something's happening is the rate of it happening. So that again is a derivative. It says, how fast, what's the derivative? How fast something is changing? Well, what's changing? Well, the thing that's changing is the distance from the top of the ladder to the ground, right? And so you have to come up with a variable. What do you want to call that? Some people might say H, because that's the height of the ladder. Some might say Y, because that's the Y-axis. Some might say B, because it's a brick wall. Some might say W, because it's a wall. You get to choose, okay? You have freedom. I'm going to call that H for the height of the top of the ladder. And so this statement says how fast. It wants to know how fast H is changing as time changes when the ladder is 5 feet from the wall, basically when B is 5. Okay? When B is 5. When the ladder is 5 feet from the wall, when B is 5. And that's going to be what we're looking for, question mark. Just to remind you, the ladder is 13 feet long, so this distance is 13. Okay, so that's probably the hard part of the problem, I think, coming up with those. Now, once you get those, then you realize, well, H is changing and B is changing. I need an equation with H and B. What do I have here that I get an equation with H and B? I told you there's 3 main types of things you're going to see. Did I say 3 or is there 4? You're going to have Pythagorean theorem, similar triangles. Oh, I forgot one. I don't know if I told you. Trig, I forgot. I don't know if I put that on a list on the thing. Trig equations and did I say similar triangles yet? Similar triangles, trig, volume area, and Pythagorean theorem. And this should be clear that it's Pythagorean theorem. You should see from this b squared plus h squared is 13 squared, right? So there is our relationship. Now we want to change these to rates, so we're going to take derivative with respect to time. Again, b is a function of time. The length of b changes with time. So does h change with time. So those are functions. Our variables are t's. Okay? So what's the derivative of box squared? 2 box times the derivative of the box. What's the derivative of box squared? 2 box times the derivative of our box. And the derivative of 13 is 0 because it's a constant. Okay? I will divide everything by 2 and get rid of these because I'm dividing by 2. And 0 divided by 2 is 0. So now we have this equation. Okay, now they want it when b is 5. So let's do that. They want db dt when b is 5. They want, that's an h. That's an h. They want dh dt when b is 5. All right, I can do this. What is b when b is 5? Duh, that's 5. And the units is feet. Do I know db dt? I sure do. db dt is 0.5. So that's going to be 0.5 feet per second plus, do I know h? When b is 5, do I know h? When b is 5, do I know h? You can figure that out. Because we know that b squared plus h squared is 13 squared. So when b is 5, we can calculate h squared. H squared will be 169 minus 25. H squared will be 144. H is 12. H is 12. How nice. So we're going to plug that 12 feet here. And we're searching for the h dt when b is 5. I can do this. This will be 2.5 square feet per second plus 12 feet times dh dt. I'm going to subtract this from both sides. So I'm going to get 12 feet dh dt when b is 5 minus 2.5 square feet per second. Now I'm going to divide both sides by 12 feet. Cancel, cancel. This is beautiful. dH/dt when b is 5 is one of those feet will cancel one of those feet, right? And I'm going to get negative 2.5 over 12 feet per second. And again, you multiply by the reciprocal 12, which is 1 over 12. So all that's on top, and the 12 seconds on the bottom. So that's your answer. You could divide that. Let me see what the book does with that one. Do they divide it out? 23. They changed to 5 over 24. Here's what they did. They multiplied by 2 over 2 to get rid of that decimal. So you don't have to, but that's what they did. And again, does it make sense that it's negative? Okay, if dH/dt is negative, that means h is decreasing. Is it decreasing? Yeah, because this ladder's falling, so h is decreasing. There is our answer. Dun, dun, dun.